Hi guys, this is iBobly with PioSolver. In this tutorial I'm going to be showing you how to interpret everything in the tree building and calculation tab. The first place we want to go to is the tree building parameters, where we set all the criteria for the situation that we're going to be solving in this section. Let's go first to the board. If we're solving a flop spot, we want to have 3 different cards here. A turn spot would have 4 and a river would have 5. We just use the standard syntax that is used in pretty much all poker software. So here we have a flop spot where the flop came ace of clubs, ace of spades, ace of diamonds. Next we go to the starting pot. This is the total amount in the pot at the first decision point that is faced in the tree. It's important to note that all that matters is the amount in the pot. It doesn't matter how you got there. As long as the ranges are the same and the amount of money in the pot is the same, the optimal strategy will be the same. So while in this spot I'm sort of considering a situation where the small blind raises to 40 in a heads-up situation and the big blind 3-bets to 90 and the small blind calls, it would be the same if the small blind had just raised to 90 and the big blind had called. As long as the ranges are the same and the pot size is the same, the strategy will be the same. Next is the bet sizes, which are a fairly complex issue that I'm not going to be dealing with completely in this tutorial. I'll have a separate tutorial to cover that. But the basic idea is that at every decision point, the player has a choice between folding, calling, or making the smallest bet available here. So at the first decision point, the big blind will have a choice between betting 60 or checking. If he bets 60, the next player will choose between raising to 150, calling, or folding. On the other hand, if he chooses to check, the next player will have a choice between betting 60 and checking. And the final raise would be to 410. Since there's no number past this, it's impossible for the pot to face a bigger bet than this, which means the effective stack sizes are 410. Since there's 180 in the pot, 90 contributed by each player, that means that pre-flop we started with 500 chips. Start the tree with out of position decision. In general, you don't need to check this because you'll play around with this, but you'll find out that usually the out of position player will almost always check. Sometimes he'll bet some small frequency, but that just adds a lot of complexity to the solution. It'll take it a lot longer to solve, and it doesn't really add to your expected value at all. In this situation, I am checking it because the ranges that I've set have given us a spot where the big blind has 3-bet. He has a lot of really strong hands, so I expect that out of position he's going to be continuation betting, so I've chosen to check it. And then the ranges you set similar to the way that you set ranges in any other software. You have this nice little window here. You can click on an option to select it, click it to remove it. We'll cover your options here more in a future tutorial. There's a lot of different ways you can specify exactly what range you want. So that covers the parameters. Now, if you are dealing with similar situations a lot of the time, you can save those parameters here and name them, and then you can just select them here when you want to deal with it in the future. So in this situation, if I'm choosing that this is going to be my big blind 3-bet strategy, I can save that as big blind 3-bet, and anytime I want to deal with the 3-betting situation, I can just select that from here. Once you've finished with this section and decided the situation that you want to deal with, the next step is to build the tree. All you do is just click this Build Tree button. I had a tree in here before, so I just have to click OK to say that I'm removing that tree. What that does, the software is now figuring out exactly all the different steps that might happen throughout this game. Once it's figured that out, it can start solving the game to figure out what your optimal strategy is within that tree. So we've got the message here, build tree OK. To start solving, we just click go. So I've let the solver run for a minute or two just to give us a little bit of information to analyze on the right. This right window over here is going to give you various statistics on what the solution is looking like so far and how close to the solution that you want to be analyzing PioSolver has gotten to. So let's look at the very last statistic that has been outputted. You get the EV of the hero and the EV of the villain. Okay, well, let's just go to this one over here. So the EV of the hero will be the out of position player, And here we see that's 113 chips. Starting pot was 180, so that's pretty good. The EV of the hero is about double the amount of the EV of the villain. That's not so surprising because he was the aggressive player pre-flop, and it's a very, very static board. So it's not too surprising that the hero has a much higher expected value than the villain. The next two numbers are the MES, the maximally exploitable strategy. So PioSolver not only tells you what the best possible strategy is, it tells you if somebody else knew what your strategy was, how well would they be able to do against you. So when it gets to be a perfectly optimal solution, that would be the same as the EV. But here it's helps you know just how far you are from the actual solution. So if you knew what villain's strategy was, hero could in this instance make 114 chips as opposed to 113 chips. So it's clearly not very easy to do better than the solution that PioSolver has given us so far, because you could play perfect and you're only making one additional chip. It's the same thing for the villain max exploitable strategy. It means if I knew exactly how hero was playing, how badly could I beat him? In this case, it's a little bit better, because I guess hero strategy still needs a little bit of time in the solver before it gets really strong. You can make about 2 chips, still not very much. And that's just summarized here in the exploitable for statistic, which tells you how many chips is the strategy that PioSolver has come up with, exploitable for, by somebody who knows exactly what the strategy is and plays the exact best strategy against it. So 1.758 chips in a 180 pot situation, that is very, very little. And the exploitable for number divided by the starting pot number will give you this right over here, which is what you generally want to be paying attention to while creating a tree, because as you saw, following it on the right gets kind of complex. You get new statistics popping up all the time. So it's good to just look here, exploitable for what percentage of the pot per hand. This percentage will give you the best idea of when your solution is ready to be analyzed. There's no strict rule for what percentage you want. 0.0% would be a theoretically optimal solution that it will be impossible for anybody to ever beat, but it's not worth waiting till it gets that far. As a general rule, if it's 3%, it's pretty inaccurate. 2% is still not that accurate. As soon as it's under 1%, you've got a decent amount of accuracy. If it's around 0.6%, then it's very accurate. 0.3% would be incredibly accurate, and anything lower than that is just overkill. So usually if you're around 0.6%, you can be satisfied with ending the tree. But if you want to be really sure that you have a great solution, then you can wait till it's a little bit lower. This is already really low. So once you've decided that the strategy that PioSolver has come up with is really freaking good and you want to start analyzing it, you click stop. You get the message that it's stopped. You didn't necessarily get this output, might have come, a minute before you click stop. So if you want to just see exactly what the statistics are and the solution that you're dealing with, you can click calculate result, and it'll pop up here on the right exactly what the statistics are for the solution that you're going to be analyzing. And that covers everything that you have available to you in the tree building and calculation tab. Next is where it gets really interesting, and we look at the browser, which will happen in a future tutorial. Thanks for watching. If you're interested in purchasing PioSolver, the link is in the description.